Hey guys, this is a review session for the geometry, Mr. Swanson's class, on level geometry class, review video for the final. This is fall semester. Um, Remember the objective here is for you to work this packet out on your own first. Don't just come over here to watch the video just to copy the answers over. So either complete it first and then check your answers. You already have the answer key posted. This is just for me to explain some things on here, along to go with the answers that Mr. Swanson already posted. Yeah, so all the best. I'm sorry that I'm not going to be around to be in person with you, but I hope this helps a good deal. Okay, let's get started. I'm actually going to turn off my camera because my computer runs too hot when the camera is on. Give me just a second here. What's another name for line L? Line L, you can name that any number of ways. You can call that DE, or you can call it EF. I'm sorry, EF or DF. Any of these. DE would work. Make sure you have the correct symbols. You can call this EF if you wanted. You can even call this DF. Any of those three answers would work. You don't need all three, just need pick one of those three. Name 3 points on the plane. Points on the plane P to be exact. So we're focusing on this plane right here. And those points are point A, point B, and point C. Yes, do separate your points with commas. All right. Name the intersection of planes P and N. Okay, so when two planes intersect, planes intersecting, they form a line. Remember, that's one of the postulates. Planes intersect to form a line, so that would be this line here where the two lines are meeting. That would be line AB. Make sure you have the correct symbol. A line has arrows on both ends. Name 3 non-coplanar points, any 3 points that are not on the same plane, okay? So we could possibly say points A, C, and D. Pick any 3 points that are not on the same plane. Here's A, it's like on the intersection of 2 planes. Here's C on plane P. Here's D on plane N. Any 3 that are not on the same plane, non-coplanar. Question 5. Find the length of line segment DE if D is between points C and E. CD is 6.5 and CE is 13.8. So for question 5, you might want to sketch this out. So we know that we have a point CE. So one endpoint is C, the other endpoint is E. And D is somewhere in between those. So I'm going to say D is like maybe right in here. And we're given D as 6.5. So from here to here is 6.5 units. I'll leave the units because I don't have a whole lot of space. We also know that CE, the entire line, is 13.8 centimeters, like so. We're being asked to find DE. This is the segment addition postulate. We know if we took CD, added it to DE, we would have the whole line CE. Now we plug in numbers. CD is 6.5 plus DE, which we don't know. Can I just call that X, the unknown right here, equals CE, which is given to us at 13.8. Now this becomes an algebra question, which means you can solve for X by subtracting 6.5 from both sides. In doing so, you're going to find out that X equals 7.3 units. So the length of segment DE is 7.3 centimeters. Okay, on to the next question, number 6. Find the length of XZ. XZ is the entire line right here. Again, this is segment addition postulate. If I take XY, so XY, and I add it to YZ, I get the whole line XZ. So let's plug in the values in there. All right, so we have 8 plus 2x plus 7 equals 4x plus 3. Again, this is now algebra. So we get 2x plus 15 equals 4x plus 3. You subtract 2x from both sides. And I'm running out of room, so I'm going to move this off to the right a little bit. These cancel. I'm going to move the solution to that here. I end up having 15 equals 2x plus 3. And I'm going to subtract 3 from both sides. And then we end up having 12 equals 2x. Divide both sides by 2. And then you'll see that your x value equals 6. So x equals 6. But see, the question was not asking for x. It was asking for the length of xz. So I have to plug in what I just found, my x value, back into xz. Remember, xz is this part right here. So I'm going to plug in a 6 into the 4. It'll be 4 times 6 plus 3. So that's 24 plus 3. That's 27 units, 27 centimeters to be. It doesn't say. Oh, yeah, it is centimeters, 27 centimeters. That's the answer to that. Okay, moving right along. The next question. A square has side length 2.3 feet. What is the area of that square? So I'm going to sketch a square. One thing about squares is that all sides are congruent and every angle is 90 degrees. That's not relevant to this question, but I'm just reminding you these facts because you might need them later. So area of a square is found by taking the side and you squared it, side times side. So we have 2.3 times 2.3. So the area would be 5.29 feet squared. And then we are next question. We are told, just use this color. A circle has a circumference of 6 centimeters. Find the diameter of that circle. So the circumference of a circle has a formula, pi d. Or you could even use circumference equals 2 times pi times the radius. They do the same job because when you double the radius, you get the diameter. However, since this question needs diameter, I think we should just use the top one. Well, since we have a formula, we can plug and chug, right? So we know the circumference is 6. So I'm going to plug in a 6 for circumference equals pi, which is the number, times the diameter, which is what we're looking for. Now, again, we have a algebraic question to solve for the diameter. I'm going to divide both sides by pi. And I believe you can use your calculator for this, but if I'm not mistaken, I think Mr. Swanson loves answers in standard form, which means don't make this a decimal, just leave it at like it is now. So it would be 6 over pi centimeters for the diameter of that circle. Okay. Now, moving right along, question 9. Find the distance between point A and B. There are several ways to do this. The quickest way is to maybe connect the dots between A and B. And out of those, that's the length that we need. Why don't we make a right triangle out of this? So we can use Pythagorean theorem. Find the distance, this distance over here, the distance across. That's 1, 2, 3, 4, 5, 6, 7 units. And the distance up here, the vertical distance, 1, 2, 3. So using Pythagorean theorem, we go a squared plus b squared equals c squared. And c is always the hypotenuse, the distance that we are looking for. So we have 3 squared, the shortest leg, plus the middle leg equals the longest leg. So 9 plus 49 equals c squared. 58 equals c squared. And to solve for c, you're going to have to square root both sides. Square root here, square root there. So you will see that c equals the square root of 58. That's the distance between A and B. And yes, again, leave the answer in exact form. Don't turn it into a decimal because that's preferred in math generally. All right, so that covers question 10. Question 9. Question 10 says, find the coordinates of the midpoint of CD. Well, again, I think we should start off by just connecting C and D like that so we can see those clearly. We need the midpoint between those two lines. Remember, midpoint has a formula. The formula for midpoint is as follows. I'm going to say MP for midpoint. You average the x's, x2 plus x1 divided by 2. That gives you the x component. And then you average the y values, y2 plus y1 divided by 2. So the 2 points that you're going to be using, point C is -2, -1. And point D is 1, 2, 3, 4, 5, 1, 2, 3, 4. Looks to be 5, -4. You can label the first pair x1, y1, and your second pair x2, y2, just so you're not confused as to what goes where. So let's proceed. We're going to do x2 plus x1. So we have 5 plus -2 over 2. That gives us the x value. All right, and then we're going to do y2, which is a -4 plus -1 divided by 2. All right, so when you simplify this, you end up having 3 over 2 for your x component and -5 over 2 for your y component. That is the midpoint. Okay, question 11, moving right along. We've got find the coordinates of a point E if C is the midpoint of AE. Okay, so I think we're using we are using the same diagram. So I'm going to clear off the old numbers that we have on it so we can have a clean look. All right, let me use something brighter so it stands out. Find the coordinates of point E if C is the midpoint of AE. So C is the midpoint of AE. So we know it's sort of like does that. Yes, we can use math here to do this problem, but you can probably already see that E would be over here because we went 1, 2 down over 1. So we'd have to repeat that on the other side, 1, 2 over 1. So the coordinate there appears to be -1, -3. So we'll look to see, we do this mathematically, see if we get the same answer, but I'm thinking that's the answer. Okay, anywho, so mathematically, remember, midpoint has a formula. There it is. We are averaging the x's and averaging the y's. So look, for point A, which is one of the endpoints, it is -3, 1. C, which is the midpoint, is -2, 1. We're looking for E, which is unknown, the other endpoint. So in our formula, we can say, let's call these the unknowns x2, y2. That unknown endpoint, we'll call that y2 and x2. And then we'll call the first endpoint, the known endpoint, x1, y1. So we can just say, let's average the x's. So it'll be x2 plus the known x1, which is a -3, divided by 2. That gave us a midpoint of -1. And then we'll repeat that for the y values. We'll say y2 plus the known endpoint, which is a y1, so 1, divided by 2, give us a midpoint value. The y component is -3. Now we can solve for this using algebra, right? First of all, for the first one, you're going to multiply both sides by 2 like that. These 2's are going to cancel out. So you have x2, let me use green so it stands out a little bit more. x2 minus 3 equals -2. And then we'll solve for that in a moment. We'll just add 3 to both sides. Okay, so we'll add 3 to the left and 3 to the right. Hang on a second. Oh, wait, guys, I think I made a mistake. We should set that equal to -2 because the midpoint is -2. Let me show you real quick. See the midpoint? The x value of the midpoint is -2. I wrote down a -1, which is a mistake. That should have been -2. So I'm going to change that to -2. The x value should add up to -2. You guys get that? Hopefully. Let me fix that real quick. In fact, I set both of them equal to the wrong thing. So I got to fix both of those. Give me just a moment. So the midpoint was a -2, 1. So I should change these. Get rid of that because that's what threw me off. Yeah, so we know that the x value of our midpoint is -2. And the y value of our midpoint is 1. So what I was saying earlier is that we know what the midpoint should be. I was saying we know that the midpoint should be -1, -3, and then we're gonna check this later. So -1, -3 is what we think the answer is because we use the manual method to do it. We'll check that. Hopefully we get that answer. All right, so now let's continue with the problem. Since I'm running out of room for this one right here, I'm gonna move it right over here. Actually, no, let me move it to the right side. Move this over here. Okay, so now we have x2 minus 3 equals -2. Okay, let's add 3 to both sides. x2 ends up being, -2 times 2, -4. So add 3 to both sides, we end up getting a -1. Okay, now we do that for the y values. I'll take this. This guy, this is what we're working on now. So solving for y, let's multiply both sides by 2. These 2's cancel. So we end up having, I'm going to move this math over here. So we end up having y2 plus 1 equals positive 2. That makes sense so far? Y2. This is a negative 1, isn't it? It probably is all messed up, dude. This is a negative 1. I don't know why I wrote the wrong numbers here. This is a negative 1. This should be a minus 1. All right. This would be a negative 1 right there. Okay. So then we end up having y2 plus y1 equals negative 2. Then you're going to subtract 1 from both sides. Y2 equals negative 3. So our answer ends up becoming negative 1 comma negative 3, which is what we knew it would be using the manual method. Remember, manually we got it this way to be that answer. We've used algebra now, and it turns out to be the same answer. Okay, so on to number 12. Let's see. Find the values of x and y if UV bisects TW. UV, this line here, is bisecting TW. Bisect means cutting in half. And this is a line segment that has been cut in half. That means we know that this segment must be congruent to that segment. That's a fact. We are also given that the length of UV is 40. So this whole line here, this line, is 40 units. So we can use segment addition postulate. If we add this to this, we should get a 40. So it'll be 3y minus 1 plus 2y plus 6. That should give us a 40. Okay, so we continue. Combine like terms on the left. 5y plus 5 equals 40. You subtract 5 from both sides. You're going to end up with 5y equals 35. And divide both sides by 5. So y ends up being 7. So we've answered y, which is good. It's part of one of the 2 answers that we need. Now, how do we then come back and figure out the value of x? Here's the good news. We know that this segment is congruent to that segment. And we just found what y is, so we can plug in the y right in here because this has a y in it. So 3 times 7 plus 1 gives us a 22. We know this segment here is 22, which means this segment is also 22 because they are congruent. So 3x minus 2 equals 22. Add 2 to both sides. 3x equals 24. Divide both sides by 3. X ends up being an 8. Divided by 3, divided by 3. So your 2 answers are x equals 8 and y equals 7. Moving on to question 13. Find the value of x if the measure of angle FEG is 82 and the measure of FEC is 5x plus 11. Okay, now we're given some more information up here. Ray EC bisects angle FEG. So here's angle FEG. FEG. That angle has been bisected by the ray EC, which means the result of that is this angle here must be congruent to that angle there. Remember, we're given the whole measure of FEG, the orange angle. It's 82. So if you bisect it, each of these will be 42 degrees, 42 degrees apiece. So we're looking for x. FEC is 42 degrees. Angle FEC. This angle here is 42 degrees. So we can say 5x plus 11 equals 42. Well, subtract 11 from both sides. Let's cancel. So 5x equals 31. Then you're going to divide both sides by 5. Wait, 41. What did I mean to say? 82 divided by 2 is not 42. It's 41. I'm so sorry. It's 41. So that's 30. So divide both sides by 5. X equals 6. Each of these angles are 41 degrees, not 42. Because 82 divided by 2, when you bisect it, you cut it in half. It's 41. Half of 82 is 41, not 42. There you have it. Question 14. Measure of angle AEB equals 16y plus 10. Find the value of y so that ED is perpendicular to AB. Okay, so one thing we know about perpendicular lines is that perpendicular lines are lines that intersect each other at 90-degree angles. So if I have one line going this way, let's say this is ED, and the other line going this way, this is AB. If they're perpendicular, they're intersecting at 90 degrees. And so this question is saying angle AED is 16y plus 10. So we know that has to be a right angle, right? So let's double check this. We have line ED. I'm just going to make up a line ED here. I'm going to say line AB. I'm going to call this A. I'm going to call this B. AED. How am I draw? I'm not supposed to draw this AED. That doesn't seem to make sense. My drawing doesn't seem to make sense. ED. Maybe I should draw AED. What? AED. Find the value of y so that ED is perpendicular to AB. Well, I can't really get my sketch to look right, but what we do know is that perpendicular lines are, they equal 90 degrees. So we can say 16y plus 10 equals 90 degrees. Subtract 10 from both sides. 16y equals 80. Divide both sides by 16. Y must be a 5. Okay, question 15. Classify angle PQR as right, acute, or obtuse. This angle is less than 90 degrees, so it would have to be acute. Remember, right is exactly equal to 90. Obtuse is greater than 90, but less than 180. All right, moving right along. Next question. Find the value of y. Okay, so we're using this figure for question 16 through 18. Here's angle y. The angle that features y is right there. I immediately notice that that's vertical to this. We know that vertical angles are congruent, so 8y minus 16 must equal 72 degrees. Solve using algebra, so add 16 to both sides. 88 equals 8y. Divide both sides by 8. Y equals 11. Then the next question is find the measure of angle 1. Notice how 72-degree angle and angle 1 together form a straight line. They're a linear pair. Remember, a linear pair adds up to 180. So if I say angle 1 plus 72 degrees, I would get 180 degrees. Subtract 72 from both sides. Angle 1 equals 108 degrees. Okay. Let's keep going. The next thing that we're being asked to figure out here is the measure of angle X. Okay, so angle X is on this bottom corner. If this is a right angle, well, adjacent to it must also be a right angle. So our equation would be 10x minus 24 equals 90. Again, algebra to the rescue. Add 24 to both sides. So we end up having 114 equals 10x. Divide both sides by 10. X is 11.4. Okay, question 19. Name the polygon ABCDEF by its sides, then classify if it's convex or concave and regular or not regular. So convex means it doesn't cave in. All the corners point outward. Concave means that something caves in. I'll give you an example of concave. These are both convex because all the vertices protrude outward. Concave might look like this. Some places cave in, right? So yeah, we know by number of sides, this is a 6-sided figure that's known as a hexagon. And it's convex because all the vertices are pointing upward. And it's regular. Regular means all angles and all sides are congruent. All angles measure the same. measure, and then all sides are the same length. So it's a regular convex hexagon. Regular, let me write it in the correct order. A regular convex hexagon. Okay, so question 20, find the length of each side of polygon RST. So here's a polygon. It's a triangle. Specifically, it's an equilateral triangle because I can see all sides are equal, right? If all sides are equal, I can set this side equal to that side, right? So it'd be 3y minus 1 equals 2y plus 11. Again, we're going to use algebra to help us finish this. I'm going to subtract 2y from both sides. Those cancel, so y minus 1 equals 11. And then I'm going to add 1 to both sides, and we end up having y equals 12. So the length of each side, remember, don't leave your answer as this. Always double check to make sure you are answering the right question. This doesn't say solve for y. It says find the length of each side. So we're going to have to take that the 12 that we found and plug it into this. So it'll be 2 times 12 plus 11. So 24 plus 11. Each side is 35 units long. And since it's equilateral, we only do one side because all the sides are congruent. Question 21, moving right along. Identify the type of congruence transformation shown as a reflection, translation, or a rotation. Okay. Identify the type of congruence transformation. Okay, so we have some figure here, and we slid it. The keyword here is slide. We slid it to the left. It looks like we moved it left, or to the, if you're starting the other way around, yeah. So this, when you slide something, is a translation. This is like a slide. A rotation is like a turn. A reflection is like a flip. Since this is a slide, we know it's a translation. Find the dimensions of a rectangle whose length is 3 more than twice its width and has a perimeter of 30 inches. Okay, so length is 3 more than twice its width. So for this question, we want to define maybe, let's say length. Actually, wait, length is given in terms of width, so we'd have to define width first. Let's just say the width is x centimeters. The length, we're given some instructions about how to do the length. The length is 3 more than twice its width. So 3 more than twice its width, that's the length. If you're looking for the perimeter of a rectangle, right? Let me just kind of give you a visual here. Width would be x, length would be 2x plus 3. Remember, perimeter is adding all the sides together. We have a formula for this. We double the length plus the width. So I'm going to say 2 times x plus 2x plus 3. So we double this some more, and we know the perimeter is 30, so I'm going to actually plug in the 30 for the perimeter right there. And then here, you can combine like terms in the parentheses. Plus 3, I should say. And then distribute this guy in here and here. So we have 30 equals 6x plus 6, subtract 6 from both sides, right? So we end up having 24 equals 6x, divide both sides by 6, x equals 4. So the question was asking, find the dimensions. So we now know the width is 4 units. Width is 4 units. How is it? Oh, centimeters, my bad. We were given centimeters as the unit. And then the length is 3 more than twice that. So see right here, just plug in a 4 in here. 2 times 4 is 8. 8 plus 3 is 11. So the width is 4. The length is 11 centimeters. Okay, on to chapter 2, y'all. Okay. If xy equals yz, then y is midpoint of xz. Find a counter example. Okay. So this one is saying that the only way two segments can equal each other is if y is the middle point. So for the counter example, I would just maybe illustrate something that looks different from this. I will possibly say I have a line here named xy. And I have another line maybe here named xy and then yz right there. And I would show that yes, these are congruent. This xy is congruent to yz. However, this is not a straight line, so y is not a midpoint. And that's enough. You just need to draw. Draw it out, however you want to draw it. I think we could have even done this separate. Like you could have done xy and then yz. And we could have said these are congruent, yeah, but they're not. Y is not in the middle, so it's not the midpoint. Okay, so question 2. Suppose P is true and Q is false. What is the truth value of the disjunction not P or not Q? So P is true and Q is false. So not P or not Q. With these, I think it would be wise to perhaps come up with an equation. I mean, not really an equation, a statement. We can say, if a number is divisible by 2, just so we have something to work with, then it is even. Okay, so what we're saying is not. So the first statement is, oh, then it is odd. I'm so sorry, because we needed, suppose P is true and Q is false. So P is true, then it is odd. So Q is false. Let's see if this makes any sense. If a number is divisible by 2, then it is odd. Right? Does that make sense? So what this is saying is, if a number is not divisible by 2, or a number, I think we need 2 separate statements rather than just have one continuous one. So let me think of something else. I would say 2 is an odd number, so 2 is an even number. So that's one statement. Okay. And let me think of that. So this is statement P. Yeah, this is what I think I'm trying to do here. And then let's come with the statement Q. Let's think here. Like, chicken have 4 feet. Right. Okay. So yeah, this will work because the statement question 2 says we want to have P as a true statement. 2 is an even number. That's a true statement. And Q as a false statement. Chicken have 4 feet. That's a false statement. So now when you look at this disjunction, it says not P or not Q. Now remember with or is super friendly. You just need for one of them to be true. So we could just say 2 is not an even number, or chicken do not have 4 feet. So with or, you just need for one of these 2 statements to be true. And since we have one of them to be true, this will end up becoming a true. Write the statement, all dogs have 4 feet in if-then form. Okay, if it is a dog, then it has 4 feet. Let's make it more clear. If an animal is a dog, then it has 4 feet. Okay, law of detachment. To write a valid conclusion for the given information. So remember the law of detachments will give you fact or rule. If 2 angles are supplementary, then their measures have a sum of 180, and that's true. Supplementary angles add up to 180. And then it gives you a scenario. So one, you'll be given a fact or a rule, and then you'll be given a scenario, and you should arrive at a conclusion based on that. If X and Y are supplementary, based on this thing up here, it means that their sum must be 180. So I would say angle X plus angle Y equals 180 degrees. Or you can say, if you don't want to use the actual equation, you can use words. Either do that, or you can say the sum of angle X and angle Y is 180. Either one of those will be fine, 180 degrees. Okay, so the law of syllogism. Remember, the law of syllogism connects 3 things. You have the original statement, which is P. Then you have the second statement, which is Q. And then that second statement will be repeated again here, connecting it to the third statement, which is over here. Oh, we call this R, my bad, not P. So let's read this. If today is January 1st, then it is New Year's Day. If it is New Year's Day, then school is closed. So to use the law of syllogism, it connects the P to R. Syllogism connects the first statement P, to the last statement R. So we can write this out as if today is January 1, then school is closed. That's how you use the law of syllogism, closed. All right. So moving on to two-column proofs. Remember, the name of the game, the secret sauce for these types of questions is you got to mark up your diagram really, really well, okay? So anything that you're given or anything that you know for a fact using a postulate or a theorem, you got to mark it up on the diagram. So first given statement is AC bisects BAD. Here's AC bisecting angle BAD. So that means angle 1 must be congruent to angle 3. That's what angle bisected means. You end up with two congruent angles. Then we are also told that AC is bisecting angle BCD, which means angle 2 must also be congruent to angle 4. All right, and then we are given that angle 1 is congruent to angle 2. Oh, angle 1 and angle 2 are congruent. So I better match those marks then. I'm going to give angle 1 double mark, and if that's true, then angle 3 must also have it. Okay, so statement 1, all these givens, take them and write them in here. Angle 1 is congruent to angle 3 because this is the definition of angle bisector. All right, angle 2 is congruent to angle 4. Again, it's the definition of angle bisector. Angle 2 is congruent to angle 3. Okay, so this one is interesting. I don't know if we've seen this one a lot, but what we're saying is angle 1 is congruent to angle 3, right? Angle 1 is congruent to angle 3 because angle bisector, right? Angle 1 to angle 3. And then we said that angle 1, not really said, we were given angle 1 is congruent to angle 2, which connects angle 2 and 3. So angle 2 must be congruent to angle 3. And if you're connecting three things, we use something called transitive property. Okay, now we can say that angle 3 is congruent to angle 4 for that same reason, transitive property. Okay. For the following exercises, we've got M is the midpoint of AB, then AM is congruent to AB. So the directions here are to state the definition, property, postulate, or theorem that justifies each statement. Okay. So let's see, question 7. AB, if M is the midpoint of AB, here's A, here's B. If M is the midpoint, it makes this congruent to that. Yeah, that's true. That's called the midpoint theorem. Kind of self-explanatory, I guess. Okay, next one. We're told that measure of angle A plus the measure of angle B is 90. Angle B is 20. Equals 90. Oh, so, okay, so this one we literally just substituted. So this is a substitution property. We plugged in the 20 where we were given substitution property. Substitution property. And then number 9, we're saying if I take segment AB, I add it to segment BC, I get the whole line. Again, we've seen this plenty. This is segment addition postulate. Refer to the figure to the right. Name a segment skew to WY. Remember, skew can be any line that's not on the same plane, neither in the same direction. So it doesn't need to be parallel. So it could be any of these lines could work. I'm going to use red so it stands out. It could be this one, could even be that one, could even be that one. So any of them, any of those that you want. Just you can't touch YW at all. So any of those. You can either say VZ, SX, ST. Any of those three. Pick one, not all. Okay. Use the diagram at the right for questions 12 through 13. Given that M is parallel, so this line M here is parallel to line N. And the measure of angle 8 is 86. Find the measure of angle 13. So we're given angle 8 is 86. We want 13. What's the relationship between angle 8 and angle 13? These are same side interior angles. Same side interior. And if you remember, those are supplementary. They add up to 180. So to find angle 13, literally take 180, subtract 86 that you were given, and that gives you 94 degrees for the missing angle. Okay, find the values of x and y given that M is parallel to N. The measure of angle N is 6x minus 5. I mean, angle 4. This angle here is 6x minus 5. You're going to find the measure of angle 10 right here. How is 4 and 10 related? Those are alternate interior angles, and they are congruent. So we say 6x minus 5 equals angle 10, which is 5x plus 8. Using algebra, subtract 5x from both sides. I'm losing my voice. So x minus 5 equals 8. Add 5 to both sides. We end up having x equals 13. Part 1 is done. All right, and then we need to figure out the measure of angle 9, which is right adjacent to angle 10. So remember, these two angles, angle 9 and 10, form a linear pair, which means they are adding up to 180. Since we know the measure of angle 10, rather we can find it, x is 13, so whatever 4 is, 10 must also be it. And since we know 4 has an equation, we can plug in the 13 in there. It'll be 6 times 13 minus 5. So 78, take away 5. That gives us 73. So we know that angle 10 is 73 degrees. Does that make sense? Why does it look bigger than 73? That's weird. You do the math again. You subtract it, x is 13, that makes sense. Okay, and angle y. Yeah, I guess it's fine. It's just a lot of work. Okay, yeah. So I'm gonna plug in the 78 minus 73. It says angle 4 is 73 degrees, which doesn't look like it's 74, but it's fine. It's fine. So then we know we can figure out the measure of angle y because angle 4 and angle 9 are same side interior angles, which makes them supplementary. So what's 180 minus 73? Isn't that 107? So the measure of angle 9 is 107. So 107 equals 3y minus 10. Add 10 to both sides. So we end up having 117 equals 3y. Divide both sides by 3. Y ends up being 39. So x is 13, y is 39, and that's it. The next question, we've got for questions 14 and 15, determine whether CS and KP are parallel, perpendicular, or neither. So to determine if something is parallel, perpendicular, or neither, you need to find slope. I won't even do these. I'll just give you guys the formula so you can do it. Find the slope. And there's a slope formula, right? y2 minus y1 divided by x2 minus x1. So for CS, well, we're focusing on these first two, right? You would say x1, y1, x2, y2. Find the slope of those two guys. 4 minus negative 12 over 5 minus 1. So the slope of this would be 16 divided by 4, which is a what? Slope of CS is 4. Now let's repeat this, but now find the slope of KP. x1, y1, x2, y2. Negative 6 minus 9 over 6 minus 1, negative 15 over 5. This is the -3. Now, here's how this works. For lines to be parallel, they have to have the same slope. So for lines to be parallel, they must have the same slope. But we know these aren't because one of them has a slope of 4, the other one has a slope of -3, so they're not parallel. For lines to be perpendicular, their slopes must be opposite, which means change the signs, reciprocal, which they're not, because let me give you an example of how this would work. It would be like -3/4. As the slope of one line, the other one would be 4/3. So I hope that makes sense. So these are not, they fail that. And so these would have to be neither. They don't have the same slope, and the slopes are not opposite reciprocals of each other. So this would be neither. So you can repeat that process for question 14. We wouldn't even do that one. So moving right along, on to the next question. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. Okay, so we are given that the measure of angle ADE, this angle here, plus the measure of angle BED, this angle here, equals 180. So those look like same side. If you're looking at this line here and that line there, this would have to be consecutive interior angles, right? Because those would be adding up to 180. So which two lines would have to be parallel? We would have to say line AD would have to be parallel to line BE, right? If that were the case. And the theorem here, we are applying a theorem, so we use the word converse. This is the converse of consecutive interior angles or same side interior angles, whichever you want to phrase it, they mean the same thing. Okay, so now moving on to the next question. Find the value of x so that line A will be parallel to line B. Well, if those lines are parallel, these angles have to have a relationship. Those are alternate interior angles, right? So they would have to be congruent. We have to say 9x minus 44 equals 6x plus 10. Subtract 6x from both sides. This is just plain old algebra. And you can add 44 to both sides, even on the same step, just to kind of maybe save time. So what's going to happen? The 6's are gone. These are gone. 3x equals 55. That makes sense, I hope. Wait, hang on. 44, not a 45. Where did I get a 45 from? 44. So yeah, that becomes 54. Divide both sides by 3. X ends up being 18. So x would have to be 18 if those lines are parallel. Okay, contrapositive. So remember guys, let's actually run through this real quick. You have the statement and conclusion. So you have a statement. We have a statement is P, then Q. You have hypotheses and then the conclusion. And then you have converse, inverse, and then you have contrapositive. So converse is when you switch that order. Q, then P. Inverse is when you negate, not P, then not Q. Contrapositive is when you switch and negate. So you'd have not Q, then not P. So for our contrapositive, a rhombus is a parallelogram. We would have to switch and negate, but first we need a statement to begin with. If a figure is not a parallelogram, then the figure, I can say then it is not. Then it is not a rhombus. That should be the correct answer to this. But I guess the confusing part is, where did that come from? So when you're given like a statement like this one, you should probably first of all make a PQ out of it. You would say, if a figure is a rhombus, then it is a parallelogram. So maybe start off by doing that, write a statement, and then, so what we just did with in blue, that's this part. So then you can do the converse, the inverse. What we've done the contrapositive of it, where we switched the order and we negated. This is our Q, this is our P. So we switched the order and we negated. That's how we got this answer. All right, moving on to chapter 3, y'all. Let's keep going. You're almost there. Write the coordinates of the image of negative 2, 5 reflected in the line y equals 2. So first, graph the pre-image, which is negative 2.5, negative 2, comma 5 right there. We want to reflect that over the line y equals 2. Remember, this line here is horizontal line. So I'm going to draw the horizontal line right there. You're reflecting it. How many places is it from there? 1, 2, 3 places. I'm going to move it 3 places down. 1, 2, 3. It ends up here. So those coordinates, are negative 2, comma, negative 1. So P prime, don't forget the syntax. P prime is negative 2, negative 1. So next question. Triangle ABC has those vertices. So let's go ahead and draw the pre-image. 4, 4, 3, 2, forget. So 4, 4, 4, 4. I'm going to call that A. And then B is 3, negative 2, 3, negative 2. B is over here. And then C is negative 1, negative 1. Negative 1, negative 1, right here. That's where C is. So looks like it's a triangle, isn't it? There we have it. Now we are being asked to do what to it? Graph that and then reflect it over the y-axis. So reflect it over the y-axis. This is your like mirror, so to speak. So that point would be reflected over here. That's our C prime. 1, 2, 3, 4. 1, 2, 3, 4. This is our A prime. And B prime, 1, 2, 3, 1, 2, 3, B prime's over here. So this is our image right there. And I believe your Mr. Swanson wanted you guys to shade the image. There you have it. Okay, lines of symmetry. How many lines of symmetry? Lines of symmetry are how many times you can cut through a figure and have 2 equal sides. So only one. This one, I think this is the only way you can cut it. So you only have one line of symmetry, and you draw it. Determine whether A prime, B prime, C prime is a translation. Remember, translation is sliding something of image ABC, and explain your answer. Let's think about this. A prime, B prime, C prime. Is it a translation? So we're looking at this figure and that figure. Oh, actually no, because if you're sliding something, it doesn't flip. Look how C's are like flipped and they're closer to each other. But this is actually a reflection. No, it is a reflection over line A. This is line A. We reflected it over reflection. I should write that correctly. Reflection over line A. The image of WX, we're given W and X along the translation vector. Okay, find the image of WX, line segment WX, over a translation vector. Remember, if you're given a translation vector, it literally add or subtract by whatever this number is. So the W prime, W currently is 7, 1, and X is negative 4, 5. If you're translating along a vector, you're going to be adding or subtracting whatever the vector says you do, right? So for the x values, we're subtracting 4. See right there? So say subtract 4 from all the x values. This will be a 3. And the bottom one will be a negative 8. And then for the y values, we're subtracting 3. So 1 minus 3 is negative 2. 5 minus 3 is a positive 2. Those are our answers. Pretty straightforward, I think. Find the image of segment AB under the rotation of 90 degrees about the origin. So if you're rotating something 90 degrees, there's a rule. You start off with the pre-image. If you rotate 90 degrees, I think we should assume clockwise. So when you rotate something clockwise, what happens? Oh, sorry. No, I think the assumption by your teacher is that if you're not giving direction, assume counterclockwise. Someone told me that in class, so just go with it. So it's going to be negative y comma x. Yeah, I believe that's the rule. So what does that mean? We're taking a and b. So a is negative 3 comma 1, and b is negative 1 comma 5. And we're rotating. So when you rotate something 90 degrees counterclockwise, notice how you're switching the order and you're making the y value a negative. So switch the order and make the y negative. So negative 1, negative 3. Switch the order, make the y negative, negative 5, comma, negative 1. Done. Just know the rules. Next question is find the coordinates of L prime prime if triangle LMN is rotated 90 degrees about the origin and then reflected in the x-axis. So again, we know the rule for 90 degrees about the origin, assuming counterclockwise motion. So we go from xy to negative y comma x. And then we're going to take whatever that point is and we're going to reflect it over the x-axis. And again, we know the rule for this. Whatever you're starting off with, you're going to flip it over the x-axis, which keeps the x's the same, but it changes the sign of the y values. So let's combine those motions. I'm going to write this as the pre-image LMN. 3, 1, negative 1, 6, negative 3, 2. So first thing we're doing is rotating it 90 degrees counterclockwise, which means we're going to switch L prime and prime. We're going to switch the order and we're going to make the y as a negative. So this will be negative 1 comma 3, negative 6 comma negative 1, negative 2 comma negative 3. And then we've done the first part. Now we're doing the second part where it's reflecting it over the x-axis. So L prime prime, M prime prime, N prime prime. This just shows this is the second transformation that we're making. So what do you do when you reflect over the x-axis again? You keep the x's the same, so the x's are not changing. But the y, the signs for the y's are changing. So negative 3, positive 1, positive 3. So these will be our answers to that question. Okay. I think that's it. So let's go then to the next question, question 8. When you rotate something 180 degrees about the origin, so 180 degrees, here's the rule. You start off with the pre-image, oops, and you end up with an image, and all you do is switch the signs. That's how rotating something 80 degrees is done, and it doesn't matter the direction. The rule's the same whether you're going clockwise or counterclockwise. It really doesn't make a difference. So that means you're changing the signs of both. So this A prime will be 4, 4. B prime would be 1, comma 2. And C prime would be negative 3, comma 1. Done. Name the image of Z, negative 7, negative 3, under a reflection over the line y equals x. So this rule, you start off with a pre-image, of course. When you reflect something over the line y equals x, you switch the order. That's it. So this Z prime will simply be these values switched, negative 3 over negative 7. So you have to know the rules. Maybe make a flashcard of all the rules so you remember them all. Okay, on to question 10. Let me see. Does the figure appear to have line symmetry? Yes, it certainly does. So if you draw a line through here, you would cut that in half, even through here, even through here, even through here. So we got those. Okay, there's more. There's actually, you can cut through here. Oops, I'm going to redraw that through the center, through there, through every vertex, basically. Like that, even through here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So this one has 8. Does the figure have rotational symmetry? Yes. I guess we need a yes here too. So you would say yes, it does. You have eight times you can rotate this. What transformation is represented? This is a reflection, like a mirror here, reflecting this way, or vice versa. Okay. Draw a translation of the given figure along the vector -1, 2. So translation, again, is sliding a figure along a vector. You're going to be adding or subtracting. So let's see. I'm going to label this A, B, C, D, just so we have values to work with. Is that okay with you? So it'll be 1, 2, 3, 4, 5. A is 1, 5. B is 1, 2, 3, 4, 5, 5. C is 1, 2, 3, 4, 1, 2, 3. Okay, so that's 4, 3. And D is 1, 2, 1, 2, 3, 2, 3. B prime, C prime, B prime, A prime. So we're subtracting 1 from all the x values, so that'll be a 0, 4, 3, and a 1, and then we are adding 2 to all the y values, 7, 7, 5, and 5. So now we're going to draw the new figure, right? So 0, I'm going to use a different color for this. 0, 7, 2, 3, 4, 5, 6, 7. And then 4, 7. Okay, so that's A and B. And then 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. And then 1, 5. 1, 2, 3, 4, 5. So we have a new figure right in that region, green one. I believe you guys have to shade the image. There you have it. What is the order of magnitude? Wait, what is the order of magnitude? And I think should be the word and rotational symmetry, but for a square, right? So if you have a square, see how many lines of symmetry does it have? 1, 2, 3, 4. So remember, order is the same thing as the line of symmetry. So we have order is 4, and the magnitude is always going to be 360 divided by the order. So in our case, it's 360 divided by 4, which is 90 degrees. So order is 4, magnitude is 90 degrees. Figure P is reflected in two intersecting lines that form a 50-degree angle. What single transformation maps P onto P prime prime? Let's think about this. So we have two intersecting lines. Okay, so we have two intersecting lines. So let's say one of the lines is here, and here's the other line, and they have a 50-degree angle between them. So I'm going to say figure P is over here. We reflect it to here first. That's 50 degrees. Okay, and then we reflect it again, 50 degrees. Okay. Right, okay, I think the following. So yeah, we would have to have 1, 2 second lines of 150 degree angle with the transformations and maps P to P prime. Okay, so we have here point P, map it here to P prime. Does that make sense? Yeah, so we're doing P prime prime. Okay, so there's another one. Oh, there's another 50-degree angle then, I guess. Because they're going to P prime prime. So P prime prime would be probably okay, yeah. So that I think makes sense. Starting at P, go to P, that's 50 degrees. But then you look closely, you go, oh, this is P prime prime. So we have yet another 50-degree rotation. So that means it would be, a 50-degree reflection. So that means the total will be a rotation of 100 degrees. That's the one transformation we could use to go from P to P prime prime. 50 degrees, 50 degrees. Yeah, so it's a rotation of 100 degrees counterclockwise in my case, but I don't think direction matters. Find the image of the points 5 and 5, 1 under a translation vector, -9 and 6. So remember with these folks, you're just literally adding or subtracting whatever the vector says. So it would be 5 minus 9 and 1 plus 6. So we end up having -4, comma 7. That's the point. Right there. It's the image. Given ABC with those vertices, find the coordinates of the vertex of the triangle along this vector. Again, vectors you add or subtract. So we're adding 0 to all the x values, meaning that the x's don't change. We're subtracting 4 from all the y values. So A prime end up being 1 comma -4. B prime, 6 comma -11. C prime, 10 comma -8. I mean, out of 10. Denominator out of 10 is a 0, isn't it? Because the x values are not changing. I don't know why I wrote a 10. Let me just say a plus. Maybe I can't read my own handwriting. Here you go. Question 18. Rotation 180 degrees about the origin. Remember 180 degrees? Literally change signs. -x comma -y is what you're going to do. So it'll be 4 comma -9. And then you're doing two things. Reflecting across the x-axis, that's going to change the y value sign. So it'll be 4 comma 9 as your final answer. Okay. So m prime prime. Okay, the next question. We're doing two things. Translating 6 units right means you're adding 6 to the x value. So let's be n prime. Add 6 to the x value. We have 11 comma -6. And then you rotate 270 degrees counterclockwise. 270 degrees counterclockwise. Here's a rule. Starting with this, you end up with -x comma y. That's the rule. Please know these rules. Actually, no, we need to switch the order. So it would have to be y comma -x. Yes. So then this becomes n prime prime. Switch the order of this point and then make the x a negative. It'll be -6 comma -11. That would be your answer to that question. And now we are on to chapter 4, which is the final chapter. I'm going to breeze through this real quickly. Ooh. Which theorem or postulate can be used to prove triangle EEF is congruent to triangle XYZ? So remember, for proving triangles are congruent, use 5 postulates: side, 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 angle, angle, side, angle. Then you have, for the ones for right triangles, we have hypotenuse, leg, 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 leg angle, and hypotenuse angle. These all go with the right triangle. So we have 1, 2, 3, 4, 5. Okay, so seeing that these are all sides are given, and this congruent to, all the sides are congruent, we would have to be side, side, side. Postulate. Simple as that. Number 2, find x, AB, BC, and AC if ABC is equilateral. An equilateral triangle, all sides are congruent. Okay. So we are finding the value of x first, then we're going to find the length of all the sides. But we just really need to do it once because all the sides are equal. This is going to be pretty simple. Any two sides, set them equal to each other. So 2x minus 6 equals 8x. That's the one I've chosen. So let's say we want to solve for x. Let's subtract 10x from both sides. So -6 equals -2x. Divide both sides by -2. So x is 3. If x is 3, we can plug in the 3 into this side. 8 times 3 is 24. Since it's equilateral, all sides are 24 units long. So x equals 3, and AB is the same value as BC, the same value as AC, and all of these equal 24 units. So those will be the two answers that you provide for this question. Question 3. Find the measure of the sides of the triangle if the vertices are this. Then classify the triangle by its sides. Okay, so to do this, I'm going to suggest that you maybe sketch this You don't have to sketch it, just a quick way to quickly see things. But I think it's the most efficient way of doing this problem. -3, -3, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Although your sketch doesn't need to be perfect, you need to at least have something realistic. So -3, 3, right there. 1, -1, 1, -1, right there. This is F. This is E. And then we have -3, -5, -3, -5. This is G. So it looks like that. So now to determine the triangle that we're looking at, we need to find the length of the sides. I like this EG side right here. That is a vertical line. We can literally just count. We are going as high up as 3 and as low as -5. So EG is 8 units long. And then for EF, we can either use the distance formula or use the Pythagorean formula cheat code that we have. So from -3 all the way to 1 is 4 units. And then from -3 to -1 is also 4 units. Okay, so that's an isosceles little triangle. So we can find the hypotenuse using Pythagorean theorem. So 4 squared plus 4 squared. You can find EF this way, equals EF, right? Squared, I guess. So 32 equals EF squared. So this will be 4√2. Now, had we done special rights triangles, I don't remember if we've done those or not, but we could have seen that pretty easily. Here we have -5. Okay, so that's 4. This is 4. Okay, so these two sides are congruent. This side is congruent to that one. So it's also going to be 4√2. So, and if that's the case, then this is a right triangle. Yeah, this is a right triangle. So it's a right isosceles triangle to be exact. And I can tell you this because the slope, this is a 45, 45, 90 triangle. Now, if we haven't covered that yet, let me just tell you how you can do this. To find the slope, you got to find the slope between E and F. Remember how to find slope? Rise over run. Or use the slope formula using the points E and F. Slope is y2 minus y1 over x2 minus x1. That's how you would find slope. Since we know E and F, we can literally use those points. So the slope for, let's say, the slope of EF. I'm only going to do one and you do the rest. Slope of EF, you would have y2, which is -1 minus 3 over x2 minus x1. It's a 1 minus -3. So we end up having a -4 over 4. So the slope is -1 for EF. Now let's look at the slope for GF, which those two lines should be perpendicular. Again, y2 minus y1. So we have -5 minus -1 over -3 minus 1. So we end up having -5 plus 1 is a -4 over -4. So that slope is a 1. Okay, so the slope of GF is 1. So as you can see, these slopes are opposite reciprocals, which tells us this is a right angle right there. So we know that two legs are congruent, hence isosceles, and it has a right angle. So right isosceles is the best classification for this triangle. Right, moving on to the next question. Using this figure, find the measure of each angle. We need angle 1 and angle 2. I want you to focus on this. Notice how this is an isosceles triangle. This angle is, this side is congruent to this side. So also, please notice here real quick, we have 120, and we can find the angle that is adjacent to it pretty easily, this angle here, because those two angles add up to 180. They're supplementary. There's a linear pair, so this has to be 70 degrees. And if that's 70, then angle 1 must be 70. Why? Because the base angles of an isosceles triangle are congruent. So angle 1 is 70 degrees, which means if that's 70 and this is 70, angle 1 is 70, this is 70, we can find the vertex angle. 70 plus 70 is 140. Subtract that from 180. This makes this vertex angle 40 degrees, which makes this vertex angle 40 degrees, right? So we'll notice this. For angle 2, we have a straight line here. 40 and 2 form a linear pair. So if 40 is one of the angles, the other one would have to be 140 because the linear pair adds up to 180. And then for angle 3, we have two angles in a triangle given. We have a 40, we have a 90. What's missing here is basically subtract 90 plus 40 from 180, which gives you 50 degrees. All right, question 7. Identify the congruent triangles and name the corresponding triangles. Okay, the congruent angles. Okay, so let's see. For this part, identify the congruent triangles and name their corresponding. Okay, so first of all, the congruent triangles are triangle, and you have to follow the same pattern that you use. Let's just do one arc, two arcs to three arcs. We'll do triangle FDG, oh, FGD, I'm sorry, FGD. So let's follow that same pattern for the other one. We did the one angle to the double angle to the two. Okay, so we did A to C to B. That's one of the ways. There's more than one way to write this, as long as you are consistent in how you write these. Now, the corresponding angles, the congruent angles, angle F must be congruent to angle A, single marks. Angle C, I'm going to keep the same order. So angle G must be congruent to angle C. And the 3 marks, angle D must be congruent to angle B. Simple as that. Are the pair of triangles congruent? If yes, include the theorem or the postulate. Okay, so you always mark up your diagram with everything that you know is true. So we're given the sides are congruent. We know from prior experience that those angles there are vertical, which makes them congruent. So we'd say, yes, these are congruent. And remember, when you have right triangles, you have a bunch of postulates you could use. Just to remind you, HL, LL, LA, or HA. This is a hypotenuse and an angle. You never use the 90-degree angle, by the way, folks. So yes, we would say these are congruent by HA. Next one. KLM is an isosceles triangle. Angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2, and this big triangle here is isosceles, which means this side here is congruent to that side, right? Okay, also, we can state just based on that statement, if KLM, the big triangle, is isosceles, then these base angles must also be congruent because the base angles in an isosceles triangle, let me draw it again, are congruent. Like that. This, yeah. Okay, anywho, so name the theorem or postulate that could be used to prove the two little triangles LPK and LMN are congruent. Okay, got it. We already have enough. Notice the two triangles that we are looking at. We're looking at this triangle here and this triangle here. We have an angle side. You guys see that? We have an angle here that's matching that angle, another angle here that's matching that angle, and a side that's matching that side. So yeah, we have enough angle side for those two triangles. Okay, next question. Find the measure of angle 1. Okay, what are we looking at here? This is this triangle here is isosceles. You guys can see this is congruent to that, which means we can figure out this base angle is also 40, which allows us to find the vertex angle up here, because that's 80 subtract from 100 from 180, that's 100 degrees. And if we know that one, then these two angles are a linear pair. So that makes this guy 80 degrees. And if that's 80 degrees, that's the vertex angle to another isosceles triangle here on this side. So these base angles are equal. This is a 40. So measure of angle 1 is 40 degrees. Does that make sense or not? Let's see if that makes sense. So we have a 40, we have an isosceles triangle, which makes that a 40 and a 40. So these two guys, 40 and a 40, that's 80. Subtract from 100 and 80, you get 100. So that's 80. Oh, I'm so sorry. It's not 40, it's 50. Because if the vertex angle is 80, 180 minus the 80 is 100. And these base angles are congruent, so that has to be 50 a piece. So angle 1 is 50 degrees. I'm sorry, it's the measure of angle 1 is 50 degrees. All right, question 11. We are looking at an equilateral triangle. I know this because it says all sides are equal, which means all these angles are congruent. These angles are equal to each other. So multiple ways to do this. If the angles are congruent to each other, why don't we just take this and set it equal to that? 15x equals 10x plus 20. That's just one way to do it. The next person might have just added all three and set them equal to 180. That's a lot of work. I would rather do this. Subtract 10x from both sides. So 5x equals 20. X ends up being 4. And that brings us to the end of this review packet. Thank you for paying attention. Thank you for hanging around to the end of it. I once again want to thank you for being awesome students this semester. Sorry I couldn't be there to go over this with you in person. Remember, if you're still having a hard time understanding any of it, Mr. Swanson is available to you during, or before or after school. So please feel free to go see him. Otherwise, I wish you a very Merry Christmas and a Happy New Year. I will see you again in 2024. Peace.